Right, so today we are going to talk about three-digit subtraction. This is similar to three-digit addition video that we discussed a few days ago. This is a similar operation except that it's subtraction. And to remind ourselves, so what are we talking about here? A three-digit number, as you know, let's talk about this number 721. The 7 is the hundreds place, 2 is the tens place, and 1 is the units place. So this is 700 plus 2 times 10 plus 1, or that is the units place. And when we are subtracting 645 from this, as in example 1 here, we need to take careful account of how these various digits in these various units place, tens place, and hundreds place play with the corresponding numbers in this the number below 645. This is slightly more complex than your normal subtraction, where you are subtracting a larger number from a smaller number. So let's do this carefully. Let's understand the steps here. So when we say this 721 minus 645, as usual, write numbers below numbers, ones place below ones place, tens place below tens place, hundreds place below hundreds place, and so on. Now we are subtracting as usual from right to left. So this is how the subtraction proceeds, from units place first, and then tens place, and then hundreds place. So I cannot subtract 1 minus 5. I cannot subtract 5 from 1. I'm just focusing on this part of the subtraction first. 1 minus 5 is it's not possible to do. 1 is smaller than 5. The way to approach this is to realize that I can borrow from the next digit on the left. So there is a number that is 2 here. I will say that okay, this number can be made 1, and I'm going to move. So because this is 10 times larger than 1, I break this. It's almost like I have 20, which is in 2 pieces. I break that into 10 and 1 here, and so I bring this remaining 1 here, and that becomes 10. So this 10 plus 1 is 11, minus 5 is 6. Same thing again. So I have a remaining 1 here. 1 minus 4 is not possible. So I take this 7 and make it a 6, and because 10 tens makes 100, so I bring another 10 over here. It's always this 10 because the number on the left is, its place value is 10 times bigger than the number on the right. So this becomes again 10 plus 1 is 11, minus 4 is 7, and the remaining one is 6 minus 6, which is 0. So that is my final answer here. This is 76. So 721 minus 645 is 76. Let's take another example that will make this a little clearer, and then we'll talk about the third one, which is slightly more complex. So this is 900 minus 548. Right, as usual, we start from right and we proceed towards the left. We wrote ones place below ones place, tens place below tens place, and so on, the standard stuff. And so now first we want to do this subtraction. I have 0 minus 8. That is not possible. So I look to the left, further left. There is a 0, and I cannot really borrow from 0. So I have to look further down. It's a 9. So I make this 9 into an 8. The 0 becomes a 10 here. This 10 is again broken because I need to further carry forward to the units place. So this 10 also becomes 9, and then this 0 becomes 10. So 10 minus 2 becomes 8, or rather 10 minus 8 becomes 2. 9 minus 4 is 5, and 8 minus 5 is 3. So that is 352. So let's go over this again. So what did we do in the first example? In the first example, we just had to borrow from one place to the right, and in the second example we had to borrow from 2 places to the right. It's like you ask your neighbor, can I borrow $100 from you? And your neighbor says, no, I don't have $100. So he then asks his neighbor on the other side, can I borrow $1,000 from you? And then he borrows the $1,000, keeps 900 with himself, and gives you $100. That's what is happening here. So this 0 tried to borrow from his immediate neighbor, which is this second 0. So this first 0, let's call it A, tried to borrow from his neighbor, the second 0, which is B. B did not have anything to give A, so he then borrowed from this 9, which is, let's call him the neighbor C. So 9 became 8. So 900, he had 900 to begin with. He now has 800, and he gave 100 total to B. B is in tens place, so that's 10 $10 bills, you can think of it that way. B kept 9 of them with himself, and one of them was given to A, which is 10 single dollar bills, let's say. So 10 minus 8 becomes 2. This 9 minus 4 is 5, and 8 minus 5 is 3. So the answer is 352. The third one is also similar, but I wanted to cover it because it uses a slightly additional concept here. So the numbers themselves are not terribly complicated, but it's the concept that matters here. So we want to subtract 267. I'm just going to write it here. 267 minus 510. Now the way to approach these problems is whenever you are subtracting two numbers, A minus B, suppose this is A and B. When you are subtracting two numbers, the rule is that you should subtract the larger numbers from the smaller number and give the sign of the larger number. So here I am subtracting 267 minus 510. The larger number here is 510. So I should really subtract 510 minus 267, because the rule is always subtract a larger number from, so that is subtract larger minus smaller. That is subtract smaller number from the larger number always, and give the result the sign of the larger number. So this 510 here came with a negative sign, so I need to perform this subtraction, 510 minus 267, and then give it a negative sign. So let's go through these steps again. So as usual, 510 minus 267. So 0 minus 7 is not possible, so let's borrow from our neighbor. So this 1 becomes 0, this 0 becomes 10. 10 minus 7 is 3, rather 3, not 7. Now 0 minus 6 is again not possible, so this 5 becomes 4, this 0 becomes 10. 10 minus 6 is 4, and 4 minus 2 is 2. So this is 243, and we have to remember to give the sign of the larger number, which was 510 had a negative sign. So 267 minus 510 is equal to minus 243. So that's how we subtract 3-digit or 4-digit or 5-digit numbers from one another. That we always subtract larger minus smaller, give the sign of the larger number, and there is the carry that you have to take into account, and sometimes we have to carry from our neighbor's neighbor, and it just cascades towards the left. Always go from right to left and borrow from your neighbor on the left. Okay, that's how we do 3-digit subtractions.